civilization is going to survive. Yeah.
Did it survive?
I don't want to talk about it. We'll focus on this love fest that is beer. And then we'll get drunk.
Last night with MLBP.
Okay, Hooman, you got your stuff in. There we go. Was that SP to MP? Where's that agenda?
It's the start.
So you are the first one. All right, I have to upload that, so bear with me. Just got it this morning. Yeah. All right, good. That means we had everything for today. We're missing one deck for tomorrow still, so I don't have to deal with that now. Thanks for getting in. I won't give you too much heat about being late.
I sent it yesterday.
What's that? It said 17 minutes ago, so
Really?
Oh,
That's when
yeah.
you open up your computer.
I was on the walk over.
Oh, maybe it wasn't my house.
Oh, it got queued up until you got back online. That could have been it. All right.
Yes. Somehow it was sent out. 506, no, that was just the 506A, which is 506B. Yeah.
All right, that's up. Now let's see if this gets refreshed. Oh, that's the problem. Okay, what to do with that? Boom. All right. We're so close. I got private instruction on how to use Chromebook this morning. Why you guys were here in MLD, but apparently we have to convert everything to Google Slides instead of PowerPoint. Should have it happen for us. We're getting close. All right, so welcome. I'm going to dive into this anyway, even though Tony's not here. So if you have anything to do, nothing, I mean, in fact, let's just say Tony's taking minutes. Just drop it on his lap before he gets here. All right, we need someone to take minutes. I know it's morning, it's a good way to stay awake. Should have made the request at the list, but you know, it is what it is. Somebody, anybody. There you go. Thank you so much. What's your email address? Okay, it's, you know, send either, actually send it beer chairs would be great. Or if you had Etherpad, send us a link to Etherpad, beer or beer chairs, and then we'll go from there. Good morning. I know that, dude. Okay, I already got someone doing minutes. What are you doing?
Why did we schedule this together with Spring?
Yeah, it must have been work. He was busy working.
Chair, why did we overlap with Spring?
That's a good question. I don't know. Because scheduling the IETF is hard, they cut a day off of everything.
They don't need podcasts.
Sure.
Well, also, make sure, because I don't remember that either you or them, but we could check that, listed each other as a conflict. So that's the other reason.
We have to both list each other as conflicts? Or
Well, no, but, you know, at least someone has to. And I don't know that they did, or maybe, I don't know, maybe we need to check that.
Let's put this in the minutes.
So next time, let's make sure that we list everything that
Yeah,
everyone
well,
cares
the
about.
trouble, I got a canned list, and I don't refresh it. We should go, because, I mean, some of the stuff's fairly new, or at least work has shifted around. So we put in the minutes. Next year, we're shooting for agenda. I'll call the list and see what kind of conflict, so we can update that. Yeah. Excellent. Note well. Everyone read and noted well?
Something's fishy.
Pardon me?
We have more presentations than people in the room. Like, how will that gonna work?
It's just 9 o'clock in Bangkok. People are slowly coming in, like you, right? You slowly came
I
in.
came fast.
Everybody's the
All right, I stopped to be funny. My chair is a serious one. He'll continue.
You opened your mouth, man. Or you stepped right in. Okay, this is the agenda we currently have. It is stuffed. We had 2.5 hours last time in Canada, and we filled that. We keep filling up time here. What I miss, we've done a couple times, is have a little open mic discussions, outstanding issues. I'm gonna try to call that anyway at the end of the day, so if stuff comes up in the conversation, we can focus some time, maybe carve up some space tomorrow, but again, it's really tight. I gave you everything you asked for in time. Normally, I don't do that. You look at it, you know, I want a half an hour, and I'll give you 10. But some of these are interesting topics, and the total came out within the window, so if we can keep this tight, make it work, get more time, I'd appreciate it. Go ahead.
Stig, I was hoping there would be some discussion about the PIM joint draft, but that's not on the agenda, it looks like.
Did you request an agenda slot?
No, but I have some comments on it, but I don't know if,
Again,
Anyway,
I threw the
I'll do it
agenda
on the
out,
list.
asking for input. If we have time, we'll do it. Is there something that you fear overlaps with here that needs to be discussed?
No, it's just that I had some last call comments that I think did not get addressed, and it could be useful to discuss them here.
Okay, okay. We'll see if we can carve time for that.
Kind of a general topic, not for this maybe, but for the next time. Can we try to group things that are similar
Yeah.
together,
We try
especially
to-
if we have overlaps? So now, like, it would be easier to manage.
So this is Greg speaking as co-chair. When I send the agenda to the list, give me the comments then. Right? That's why I sent it out there. If there's something missing or there's some association, right? So we get some feedback, and we're not doing this in the room. All right. Anything else? All good stuff. We'll try to carve out time. All right. Boomin, you're up. Okay, your presentation made this should work. It works like that.
Perfect, thank you. So I guess we did the last guard call on the PIM signaling. There were some great comments. Thank you very much, everybody. So we thought that the next obvious step is to start signaling MPLS type of solution over beer. Again, to refresh everybody's memory, the entire reason for this type of signaling of legacy multicast protocols over a beer core is some of the tier 1 operators out there, they want to replace a portion of their network, whether that's core or even access, it doesn't matter, a portion of the network, they want to replace it from legacy multicast to beer, simply because it brings simplicity from protocol layer point of view, from forwarding, all the good stuff that we know. And they need to stitch legacy protocols through this beer core. So this is why we are providing these type of drafts into the IETF.
Thomas Eckert, just a quick question. Is also anybody selling MPLS service where they're selling MLDP then as the multicast part? So not just only internally, right?
Yeah, that's a great question. So to give you an example, some of these tier 1 operators, they have wireless services. On the wireless side, they do use MLDP as an example. On the business side, they use PIM, et cetera, et cetera. So to answer the question, yes, all these type of stitching of legacy stuff are there. This is not something that we are just cooking up from our imagination. So even though that this draft is really calling out for MLDP, this is how we started. Eventually what we see is that this draft going to get extended to MPLS point to multipoint topology. What that means is that we are seeing a new multicast point to multipoint trees coming. We had a talk in PIM with the segment routing, looking at the spring, there is tree seed. So all these type of MPLS point to multipoint tunnels, they kind of need to get a stitch through a beer core. And this is a starting point, but eventually it's going to get extended to all these other point to multipoint MPLS tunnels as well. We had some new co-authors. Thank you very much. Ryzen, Eddie was there, and actually Cisco, Mishra, thank you. But basically what this draft is going to go to, and we try to keep it in line with PIM signaling, as everybody is very familiar with the PIM signaling, is 2 directions. So the first part is, from technical point of view, is the signaling part. So on the signaling, and I still kept using the term BBR, boundary beer router, ingress and egress. I know there has been some comments that maybe that term is a little bit confusing and we might have to change that. I'm completely open to that in the working group, as long as I can do a search replace with a brand new term. By all means, let's do it. And as long as we don't create extra complexity into the drafts that are being introduced. That said, so the technical part is very similar. So on the IBBR, or on the beer boundary routers, the signaling, MLDP in this case, becomes terminated and is signaled from IBBR to the EBBR. That signaling we need to identify. As of now, I just said, let's signal the FEC of the MLDP. So you grab the FEC of MLDP, you put it into a beer encapsulated packet. How you find the EBBR is in line with what we did in PIM signaling. So you look at the root of the FEC, you figure out where the root is, and you use the same procedures as PIM signaling to find the EBBR. You signal your FEC. A FEC, as we know, will represent the point to multipoint LSP uniquely within the beer domain. So what that means is that within the beer domain, we need to identify that point to multipoint LSP, if you will, uniquely. And how that's done is that on EBBR, it will assign a beer domain label. Again, I'm open to changing that name. When that label is assigned, there is 2 ways to signal that back to the IBBRs. Number 1 is via SDN. Number 2 could be via BGP. And whether we need a new PTA, a route type for BGP, again, I'm open, we can talk about that. Whether we can use the existing PTAs or the route type, something that we need to talk about from technical point of view. But that's how that point to multipoint LSP is actually identified within the beer domain. So I actually went through this slide. This is the BGP case. So the FEC comes to the IBBR. The IBBR actually assigns a label. That label, for simplicity, you could think of it as like a BGP LU label. So it will stitch the point-to-multipoint MPLS on the MLDP side to a BGP LU type of label on the beer core. And on the BBBRs, you need to swap or pop and push, whatever it is that you need to do, to stitch this tunnel throughout from the root to the leaf. The only extra part now, so one more addition part is that the EBBR, exactly like PIM signaling, tracks all the IBBRs. So the same table, the same infrastructure that we created for PIM signaling will come into play here. The same procedures, everything is going to be the same here. It's just now working for MPLS. The next part of it is if some operator decides that SDN is the way to go, 3-seat, segment routing, point-to-multipoint, as we talk into the PIM, same idea with SDN. So the control plane for advertising that beer domain label that identifies the point-to-multipoint LSP could be done via SDN, or it could be done via BGP. The entire point is that EBBR still assigns that unique label that represents the point-to-multipoint LSP. So the next part is, oh, and there's a slide missing. Sorry, go ahead.
Question. So, I mean, these are upstream assigned labels, right? So they basically need to be received, and looked upon in a context, right? I mean, you can have two different upstream routes assign the same label, or you manage a label pool, or you basically do a lookup based on the label and the BFIR in the beer packet header. So,
yes.
I mean, those, what were you thinking?
So again, between the PE, between the root and leaf is today's MVPN procedures, right? So what happens with MLDP today is MVPN procedures will kick the leaf to generate a FEC, and that FEC will be generated to the root. So it's going to have root IP address, a unique identifier of the root for that VPRN, and that's what the FEC with the OPEC, that's what it looks like. So when that FEC gets to the ingress PBR, the same thing what we did with PIM, you're going to look at the root and you're going to identify the root. So far, so good? Is that clear?
No, I mean, just look at the BFER. The BFER gets a packet, it has a label, right? So now, could it be that the same label be received from different upstream, for different trees, right? You're joined to two different trees on two different upstream
Yes.
BFIRs, and they, of course, assigned independently from each other, randomly the same label, so you get that, so you can't decide, which of the trees. You have two trees to which the same label was assigned. So how do you want to distinguish that?
Yeah, so the key is the FEC. The FEC on the IBBR will identify the point-to-multipoint LSP. So it cannot be identical.
But
Let me try to clarify.
Sure.
Cisco. So I think what Toulouse means is on the way back, right? So if you receive the packet, your beer packet, then you need to do a label lookup, determine which packet it's for. But since label is upstream assigned, it needs to be unique in the context. Right?
Yes.
But let's say the label underneath the beer header is a context label, right? In combination with the BFIR, or it's a global label, which I've proposed. A global label. Right? Then it's always unique too. So I think there are two ways to do it. Right?
Yeah.
So it's basically one more label. So you're doing a two label lookup, so to speak.
Yeah, it's a context label.
So yeah, exactly. The data path slide is missing here. Now that you have actually signaled your control plane all the way from the leaf to the root, on the EBBR, when the packet comes back, you simply do a swap on the MLDP packet compared to the beer domain label, and that keeps the uniqueness of the point-to-multipoint tree throughout the entire path. But with the same token, because you know which IBBR has advertised that fake, now you're going to put a beer header on top of that. And it makes it very simple and very in par with the PIM signaling. So that's why we think this solution is very attractive. So what is the next step? There were some good comments. I think one of the next step is we define SDN and MPLS signaling here. So we're going to try to separate those two into two separate drafts from signaling point of view, one created for SDN and the other one created for BGP. Also, we're going to try to make the draft a little bit more generalized to ensure that it fits for MPLS signaling rather than only MLDP signaling, and take it from there into Prague and see where it goes.
Can you go back a few slides? One more, one more, one more. Yeah, this one. Okay. So I read the draft, but I keep learning new things.
Sure.
That's
always good.
While we go. So that first part, number one, right, where you, or maybe number two actually, when you send out take your MLDP FAQ and you signal it to your egress BR. How do you do that? Because that's, so from MLDP's point of view, that was a TCP, coming on TCP session over LDP.
Yeah.
But now you're saying you're putting this natively in a beer packet.
Yes.
So you're coming up with a new packet format.
Not a new, and that's the part that I'm open to discuss that part,
That's
right?
good.
Yeah. So as of now, again, I just put the FEC as an IP because the PIM signaling is IP. So I try to keep the same thing. I'm going to just create the IP header and put the FEC in there and make the MPLS packet to be, the beer packet to be MPLS signaling as like a brand new beer packet type. So that way the EBBR can identify this as a signaling and extract it and do what it needs to do.
Okay, but if you do that, you still need to deal with, loss of packets, retransmission, and all those sort of things, right?
Yeah.
So Andrew was giving me heat yesterday for, trying to keep MPLS protocols alive by saying, it's dead, you use BGP.
Yes. So yeah, we can.
But it's okay to come up with something completely new here.
Yeah. So we can try TCP or something like that. It's the point that somehow we need to signal this. And there were ideas about MVPN procedures. I'm really not sure how to use MVPN procedures on a P router.
Well, so we definitely need to talk about this.
Okay.
Right? So, but I would highly recommend not coming up with a new protocol, because you're coming up with a new protocol encoding to transport this across the beer core, right? So either use targeted LDP or go with, existing signaling like MVPN beer.
Yeah, thank you. So the only comment I got is targeted LDP is not generic enough to take this to other type of signaling point to multipoint. But you're right. We need to talk about this and we need to figure it out.
Andrew Dolgan, okay. So yes, it's a valid point that we need to make sure that the packet arrives at the far end. So that enhancement needs to happen. There is certain discussions that we had of one of those, and maybe Jeffrey is standing behind, was to use MVPN procedures. MVPN procedures are fundamentally, I believe, are fundamentally wrong. The reason why is because it would introduce a edge processing in a device that's in a core. It's a P router. You're going to start doing a service awareness, edge processing at state, at complexity in a box that needs to be as unaware of this as possible. So, and I'm not even going to go into the modes of overlapping this if there is BGP running actually properly between the edges, because there may be MVPN as well running between PEs, not between PEs in this. So this is a transient case and an introduction of thing, and so there will be technologies and GMVPN running across between them. So I think, in a short, do we need to fix the do we need to fix or do we need to enhance it to prevent packet loss? Yes. We need to though remember that this is a P router in a core. So we shouldn't be introducing things that P router normally would not have. And then we can decide.
As participant,
Yeah.
+1 to ICE. Do keep what is effectively overlay signaling out of the data path. Okay. And whether you use something like BGP synchronization or targeted LDP, whatever, doesn't matter, but to resist the temptation to rely on the fact that you have the data path to graft some signaling, which is effectively, I consider that overlay signaling here to stitch all these things. Yeah, the quick and dirty hack remain dirty long after they have been quick. Yeah. That is a quite significant architectural decision. So for me, it's +1 ICE very clearly.
Jeffrey Zhang from Juniper. So we've had some offline discussions. So I want to summarize some points for the benefit of the room. First of all, if we are only considering MLDP case, then RFC 7060 will be the best solution because anyone who has implemented that only need to define a new interface ID TLV, and that's it. Everything works. And then if you want to go beyond MLDP for future other kind of MPLS P2MP tunnels, then I would argue that BGP and MAPN would be the best way to go. That's just a summary. I don't want to get into too more detailed discussion here. I guess we're on a schedule, so we can continue this discussion.
I think maybe we need to address a couple of those points, for a minute. So TLDP, yes, thank you, great option. But as I mentioned previously, it's not generic enough to work with everything. So, and MVPN procedures, I'm all ears, but the simple part of it, which I cannot figure out, and I tried to figure it out with the wine, but I couldn't either with a glass of wine, is the part that how you're gonna run MVPN procedures on a P router. So that means I gotta grab every one of those MLDP fix and somehow put it into an MVPN procedure in the PTA and send it to the EBBR. This is a brand new draft.
So, ICE. Now, I think, responding to Andrew's comments, you'd have a beer core and you want to overlay another technology on the edge, right? In a sense, that is MVPN. It's the same thing that we do with PIM over MLDP, right? So you can say, I don't want this P router to be a P function, and try to come up with all sort of a little bit of hacks to not make it a P. But at the end of the day, I think we're hurting ourselves because you corner yourself. And actually, maybe go back to the PIM version of this. One part, and you know that, right? That I didn't really like is how you discover who your EBBR is. And there are all sort of procedures for that. Well, with MVPN, you know exactly because it's defined, right? So you know who your egress border routers are. So if you're saying I want a generic way to solve this problem, and I don't want to be difficult, really.
No, so here as chair, and it would sound soapy. This is not from the draft, was kind of original first hack. This is a beautiful architecture emerging. Don't let it go lightly. Nice architectures are born in a lot of pain, okay? So don't let it go just to be pleasant, just the opposite, yeah.
So to go back to the PIM version of it, I know it's in last call, but if you say we want a generic way to solve the problem, you can also say, well, open that up again and say use BGP and transport PIM in that, right? And not unicast PIM and have all these procedures to figure out who the egress is.
Sequence on the mic.
Again, I'm just gonna put this fundamentally, if there was no MVPN in that network at all, then we could probably make this somehow happen. Somehow, I still have, but the fundamental thing. Look at this picture. That picture is a little misleading because that blue cloud is between PEs. That central cloud is between PEs. So what you de facto would do if you put an MVPN there, you would nest an MVPN inside an MVPN with the procedures which
They're independent of each other.
Okay, minimum decorum.
No.
We have to get all the Polish people under control. So first, please sequence names on the mic and stick. Thanks for volunteering for Jabber.
Andrew Dolgano, Nokia. They can be made if there is no MVPN running in the same context as we're already using, and there is. So by putting a BGP there, you can solve a particular case if the MVPN was not there between PEs. If the MVPN is there between PEs, and it is because it runs, then this is.
We need Jabber. This is too important.
All right, just Jeffrey, and then we got to cut off comments. We're way over on this, so let's Jeffrey go.
One quick point. So in this case, your border routers are not regular P routers either.
Okay, we need meeting minutes. We need Jabber. This is too important. That cannot get lost.
Next steps.
Yeah, I'm at the next step. I think I'm done with the presentation.
Minutes, Jabber, volunteers, please. Who takes minutes?
We got minutes already.
Thank you. Perfect. Jabber. Sticks playing with the phone. That could be a good thing.
No,
he's giving me dirty looks and plays selective deafness.
He's properly concerned for civilization.
Jabber, please. Someone jumps on Jabber and documents. Too important. Okay.
Okay, thank you.
Well, Jabbers just keep questions for coming in. Documentation is taking place with minutes. We still need a services people. So you can keep an eye on it there. Next up.
Okay, we have someone on the mic. Should we take the mic question?
Take the mic if you got a question.
My question.
Here, one mic.
Hi, Sunish. All right, the red button should work, but I don't see anything.
They just simply had enough of you.
Yeah, well, that's normal. Okay, Sunish, I cannot get you to talk, so long push.
Take it away.
Okay, Meet Echo is not working, it seems. Okay, keep on.
Okay, good morning. This presentation is for beer prefix redistribute. I'm Sunny Zhang from ZTE. And we have co-author Bo, Jeffrey, and Ice. And this draft has been presented in London 101 meeting, and it's the second presentation for it. At first, let's see the problem statement. It's a traditional network. According to the administration requirements, we divide the network into several IGP areas, and the IGP protocol runs in each area can be the same or be different. And the numbers of routers in each area is not even. So maybe there are tens of routers in some areas and there are only few routers in the other areas. So now multicast service has been deployed in this network by PIM protocol. But if we want to deploy beer in this network, according to the existing IGP extension, we know that one beer domain is equal to one IGP area. So in this network, we will have 3 beer domains. So the border router, like R3 and R4, must maintain the overlay multicast flow state. And R3 and R4 must do the encapsulation and the decapsulation function. So the beer forwarding efficiency may be decreased. So we'd like to improve the forwarding efficiency. So we'd like to merge the several areas into one beer domain. So we can remove the overlay state in border router like R3 and R4. So we can decrease the times of beer encapsulation and decapsulation. But the problem is how we can build the beer forwarding across multiple routing areas. Let's see the solution. So we will advertise beer info associated with prefix redistribution in border router, like the router R3 and R4. And so the beer node information will spread in the whole beer domain across multiple IGP areas. And the advertisement is aligned with the existing IGP or BGP definition. About the MPLS encapsulation, because it has local significance, so we need not but may advertise it to the next routing area. So every node in the one beer domain can build the forwarding plane. Because some prefix in one area may be hidden when the border router does the prefix distribution function, such as aggregate route or summarized route. So, or default route will be used in here. So we add a new extension for this type of route. We can call it beer proxy range subtil V. So like the format is like this. The BF IDs associated with the summarized prefix can be advertised individually in the beer range subtil V. And this subtil V can be used to improve advertisement efficiency if BF IDs are continuous. And multiple beer proxy range subtil Vs may be used if the BF IDs covered by the prefix are allocated from different ranges. So maybe we can use necessary policy to control it. So.
Stigvana, so I see here that you have this buffer range if it's like contiguous IDs.
Yeah.
Would it be an option to use a bit set instead, like a beer set, basically have bit positions for each of the buffer IDs that this prefix is for? Because then you could easily do any buffer IDs even if they're not contiguous.
So you mean we must change the, but this is 16 bits for it. Do you mean it is different from the existing IGP extension?
Yeah,
we can change it.
Yeah, just a thought, but yeah, it will require more than 16 bits. Yeah.
Okay, we can change it.
General from Huawei. Did you mean the current RFC don't support inter-area advertisement of beer information?
The existed IGP extension is one beer domain is equal to one IGP area.
Oh,
so.
Sorry, I can't agree because RFC has make it clear it can support inter-area advertisement from this area to
this
that.
route would like to solve the problem.
No, current RFC already supported.
No.
Well, this is really just a language issue, and we can fix that. It's basically in the use case that Sandy brought up, you actually have different IGP domains. For example, you have one OSPF domain and another OSPF domain that are not really different OSPF areas. But anyway, the language could be more clear.
Okay.
Yeah.
Okay. General again, and again about this picture. Current IGP underlay for beer, I think it can do the same thing to advertise the opaque LSA with a conversion from, for example, ASS to OSPF opaque LSA one by one.
Yeah, only one by one. But with if we want to advertise multiple summarized prefix, how can I advertise it?
You mean this can make things more efficient?
Yes.
Okay, that makes sense.
No. It's because when we advertise prefix from one area to another area. We can use default route. And we not advertise the BFI IDs one by one. So how can I advertise it?
Okay, makes sense. Thank you.
Thank you.
All right.
Okay. So we think the question will not influence the content of this draft. May I call for?
Who's read the draft? All right. Who thinks should be adopted as working group item? We're there. All right, good. We'll take this to list. Please note that in the minutes, and we'll call for support. Excellent.
Okay.
Thanks, and you're up again.
Okay.
All right.
Okay, this presentation is for global VPN ID advertisement in BIER overlay. We have co-author Shaofu from ZTE. I'm still Santi-san from ZTE. Whatever the solution is, let's see the problem statement. And we know it's simply L3 network. And there's some BOM requirement in this network. And we use BIER to provide the multicast service in the connected area. And we want a simple solution to solve the BOM isolation. Like the gateway list here is not the provide agents router. Even if MVPN, MPBGP will not run in the gateways. So if we would like to solve the problem, maybe we can use MVPN. But we know that this will increase the burden of the gateways, and some service provider will not like the MPBGP maintenance. So maybe we can use controller in this network, but we know that controller will not be available in some situations. So it's a simple solution for it. It's something like the last presentation from Horn. So we borrow a name global VPN ID from FC 2685. We use it in BIER overlay control plane and also in the data plane. So we use BIER overlay protocols to advertise the global VPN ID, and also we use the global VPN, the value of the global VPN ID in the data plane forwarding as a context. And we will add a new protocol type which indicates the global VPN ID in the BIER header. Like the VSID uses in BIER EVPN, but we will not use MPBGP advertisement. So we'd like to use MRD or PIM to advertise it. But if you want to, you can use BGP global advertisement for it. So if we use this solution, we know that we can use global VPN ID 1 indicates the group 1, like client 1 and client 4 and client 5. And we use global VPN ID 2 indicates the group 2. The group 2 includes client 2, client 3, and client 6. So the gateways, like gateway 1, 2, 3, 4, will advertise associated global VPN IDs to each other. So the ingress router, suppose gateway 1, can encapsulate the BOM packets from client 1 with the global VPN ID 1 as the context, and encapsulate the outer BIER header with the gateway 2, gateway 4 as the bit string. So when the packets reach gateway 2 or gateway 4, the egress router will remove the BIER header and find the context value, global VPN ID, and forward it to the associated client 4 and client 5. So we think this solution is very simple for simple network that does not run MPBGP. So, but we are open to the other solution for this network. So if you have some suggestion and comments, please. Thank you.
General from Huawei. I think this add a new identification to identify the VPN is a good idea only for the non-segmented VPN deployment. If segmented is deployed, then the ABR or the segment point will have to allocate such a resource dynamically. So that's that will make confusing. And again, I agree with the idea to add a beer proto value to make the global identification beer specific, because the current MPS pool is very busy. So summary, I agree with the idea to add a new beer proto to beer proto value to identify the beer specific global VPN ID. Thank you.
So if somebody has a new or good suggestion for it without the new protocol type, we are also welcomed, because we know that because the context may be different. If each solution allocate one prototype, I don't know if it will be enough. So it's just a question. And the network we want to solve is listed here. So please, we can work for it, and it will deploy, increase the deployment of beer technology. So every comment is like.
Okay, Xie Jinrong again from Huawei. I want to make to be clear about the beer proto value 1. Whether it means a beer specific global VPN label or a pair platform MPS label. If that means a beer specific label, then there's no need to add another beer proto. But if it means the pair platform MPS label, then there is need to add a beer specific one. That's it. Thank you.
Any other comments?
We're really already behind here. We had some good conversation. I want to cut off, but this one, let's just try to move this forward.
Okay.
Slides here, we done?
Thank you.
Oh, wait, you didn't get to the end of your slides, or did you go back one? Get back up. All right, Stig. Thank you, Sandy. I got you first as your MTU. Just try to be
Yeah.
if this works. You're in charge.
Okay, thanks.
I believe in you, Stig.
All right, so a quick update on the MTU discovery draft. There's a slight technical issue here.
Hit the right button. Or try the up down button.
Okay, maybe this works. Okay, it's good right now. Okay. All right, so as you may remember, the idea with this draft is to find an MTU that can be used in an entire beer subdomain. So all the routers announce basically the local MTU, what they can see from their local interfaces. And by comparing the MTUs announced by all the routers, you can see what is the MTU for the subdomain. And the idea is that this is easier than doing a path MTU because it doesn't change. And so as long as the packets are within this MTU, you are sure that they won't get dropped if there's like path changes and any path changes. So the changes since last time is basically that I'm saying now that you announce the size, the maximum size you can forward after encapsulation. So it's not the IP MTU, like the largest IP packet you can encapsulate, but you announce the largest beer packet you can send after encap, which to me at first seemed strange or not as good, but it works because an ingress router knows what its encapsulation overhead is. So a beer ingress router knows, based on its encapsulation, what the largest IP packet it can encapsulate. And that can make it through the PIM domain. Basically you just check how many bits or bytes do I add as part of my encap, and you subtract that from the subdomain MTU. That gives you the maximum IP packet that you can tunnel through beer. I also added some text based on discussion last time that implementation should have some configuration that can specify a minimum MTU. So basically, let's say you decide to use jumbo frames in all of your beer network, but you accidentally bring up a link with a smaller MTU. Rather than having the entire beer domain revert to that small MTU, you then ignore that particular smaller MTU, and you can do like some kind of warning to administrator that a too low MTU has been detected in the network, something like that. Which means though that any packets that unfortunately try to go through that one link might get dropped. So those are the changes since last time. So I'm wondering if the working group wants to work on this, or if there's any other changes we should make to the draft.
So who's read the draft? All right. Who thinks this is something we should adopt as a working group? Excellent. All right. Note that in the minutes. We got some AD comments. Move to the head, please.
Hi, Alberto Rotana, routing AD. I'm not opposed to working on this, but I'm concerned that if this is adopted and it progresses, we need to get transport people on board, because the whole point of discovering the MTU, the path MTU, is precisely avoid the problem of I now put a smaller link and everything fails, right? And what you said there is we just ignore that and we just keep sending the bigger packets, right? Which is against any end-to-end transport connectivity thing. So what that means is we're of course not going to get this past the IAG, right? Because everyone in transport is going to jump up and down. So make sure that as a working group process that we get early transport area review or something when the time comes, so that we address everything they say and we say, yes, we don't really care that the packets don't get to the other side, something like that. That's really not going to fly, because it's going to be a big problem if we can't guarantee connectivity across the network, because we're ignoring the link that we know has a lower MTU.
Alvaro, a bean counting question. To get it into the transport area early technical review, does it have to be adopted as a workgroup document? It goes as individual document for an early review?
I think that it only makes sense to send it to them if the working group thinks this is going to be published, right? So, at this point, if it's not adopted.
Just for direction to the chairs, to the list, what do you think? TSV, the whole area group?
You may want to send it to the TSV working group. There is a TSV review group.
Okay.
If you ping me later, I can maybe find where it is, or you can talk to the transport ADs and have them ask for the review. I think, in fact, now in the data tracker, you can go, there's a little thing that says request review, and it takes you to a different page, and you can request from the TSV or from routing or from whatever you want. And put notes there, any concerns you have or whatever you want to do. So you as chairs can do that. You don't have to ask anyone. If you can't, or it doesn't work for the TSVs, just let me know and we can figure it out.
Good input. Thank you very much. Okay, next item.
Yeah, sure.
We call for adoption.
I said, yeah, call for adopt, and then
Okay.
once we get support on the list,
Okay,
then
that's
we'll,
fine.
before we accept it, we'll go to the request review button.
Cool.
Yeah, all we do is click web buttons now.
All right. So in PIM, we have a new mechanism for announcing active sources that can be used to basically do ASM with shortest path trees only, you can say. I'll explain more on the next slide. And I'm looking into, if you have a beer domain in the middle of a PIM domain, how can you make sure that these messages can traverse beer so that you can use this in PIM as if there was no beer in the middle, kind of. But also how this can be used to actually help PIM joint signaling over beer. So in PIM, we have this RFC 8364. The idea, as explained here, is that any router that has directly connected sources, instead of kind of sending PIM registers, you are sending something that looks a little bit like BSR. You are sending messages that get flooded throughout that PIM domain saying, here are my active sources, the directly connected sources. And this is flooded through the network. So if you have a last stop router and you get receiver interest, you can then join directly to the shortest, towards the source on the shortest path tree. So at least some of us think this is a nice thing. We want to use this in PIM. And I'm thinking, if you deploy beer, I also would like some way for this to work. So basically, if you have this situation here, I have two clouds that are PIM domains, and then there's like this cloud in the middle is beer. Basically, you have maybe had one big PIM domain, and you replaced or upgraded some routers to do beer, kind of like the PIM joint signaling over beer scenario. So what would happen then with this PFM mechanism is that the first up router to the left there, connected to the source, would announce an active source. It gets flooded throughout the PIM domain on the left, and we somehow want those messages to reach the PIM domain on the right and towards this last up router so that we can make use of this mechanism. So what I'm proposing is that when an ingress beer router, basically a beer router connected to the PIM domain on the left, receives an announcement like this, they should send the PFM message to all beer routers. And then any edge beer routers, including the one on the right up will get that message, and they can then forward messages in the beer domain on the right here. So it's a way of making sure these messages can pass through beer to any PIM routers that need to get them. So that's one thing. The other thing I'm trying to do is to solve this problem in the PIM overlay, PIM join draft with how do you determine which router to send a PIM join to. We want to find the beer router that is closest to the source. And the way I'm proposing to do that is that when a beer router on the left here, what I call an ingress beer router, encapsulates this PFM message, it adds, one thing is it adds a new TLV with its beer prefix, subdomain, and beer ID, just to identify the ingress beer router. And for any S, G TLV, it replaces that with a SG metric TLV. Basically, it says not just that it's an active source, but it's metric towards the source. So by doing this, you can find out which of these ingress routers are is closest to the source. So if you look at this scenario here, basically the router on the beefer on the right here, would cache these announcements. So when it receives a PIM join or interest from the PIM domain on the right, it can go and look in its cache and find out which S, G is closest to the source. It will compare like metric 1 and metric 2, and find out that maybe B for 1 is the closest, and send a PIM join towards that. So it's fairly simple. One thing I should have said on the previous slide is we're changing these TLVs in the beer domain, but on the egress, we revert to the original S, G TLVs. So in the PIM domain, you don't see any of these new TLVs. It's only as the PFM message goes through beer that you would add the metric for the source.
Human Bitcoin and Nokia, quick question. If you could go back one slide.
Yeah, sure.
So on that picture, the routers that have the 3 green.
Yeah.
So are they like encapsulating the PFM within the beer packet, or?
Yeah, you basically add a beer header and you set all bits. You send it to kind of a broadcast to all beefers.
So in this case, you don't need to find the BFIR or IBBR or whatever it is that you're going to call them, because you're broadcasting. You don't need to really find that, right?
Yeah.
Okay, gotcha.
So you can say, one thing I want to add here is, in the IGMP overlay, we are broadcasting the receiver interest to everyone because we don't know where the sources are. Here we are kind of doing the opposite. We are broadcasting the source information, and an additional thing we can do here is also send directed IGMP reports. So they just go to the routers that actually have active sources, reachability to active sources.
Thomas Eckert. So the joins, are those unicast?
We're talking about these joins here?
Yeah.
That's according to the PIM over beer draft. So basically, they're unicast. You put on a beer header with a beef ID that you want to send a join to.
Would maybe be useful to open up the discussion whether, the procedures would work better if they would also be, beer casted, so to speak, to, all the scene upstream, so that any switch over, right? I mean, what happens if multiple downstream? It's kind of this assert problem, right? So this is like, what's the best, LAN procedures for multiple downstream, multiple upstreams, if they get the additional indication, who is able to send, and right?
Yeah. So I would say, if you think about, maybe like reliability and stuff, it could perhaps be useful that B41 and B42 both receive that join. Yeah. But you would need to have some kind of forwarder election and some way of maybe one start forwarding if the other one goes down or something like that.
Well, right. All I'm saying is, right, we've got beer, so there is no need to use unicast just because we forgot to be able to send it upstream to all the possible upstream routers. I haven't tried to think about whether, I guess in this case we wanted, so it's better than a LAN, right? We can have different downstreams select different upstreams. But here, I think you're making the assumption that everybody should select the same upstream anyhow because of a single metric.
Yeah.
Or would there be, I don't know, other criteria?
No, I think in the PIM join draft, and also here, the idea is that everyone hopefully sends the join to the same upstream router.
Yeah, but then you haven't showed a really interesting beer domain, right? This BFIR1 and the BFER1 can be, both in the US, and BFIR2 and BFER2 can be in Europe. So, the cost across the beer domain is not taken into account. I don't know if we can or should do it. All I'm saying.
Okay, I see.
So this is cool and interesting. I'm not sure, more raising questions than answers. The only thing I know is I would love to not proliferate this wonderful PFM SD name any further. That's really come up with a simpler name.
Right. So we haven't thought much about this, but I guess if you want to account for the cost across the beer domain, one option perhaps could be that the egress router, the BFER here, basically takes the metric announced and adds the cost to reach the beer prefix of either BFIR 1 or 2. So you can see what the total cost is.
So just one Nokia, just one more question. If you go to the previous slide. So this procedure is happening before the PIM signaling procedure, I guess. So when the PFM SD comes into the BFVR, I want to say, what are the left-hand side routers? Those are the BFERs or?
So basically the message would get flooded throughout the PIM domain on the left.
Right.
And any border routers on the left of the beer domain there, they would forward it into beer.
So you're gonna set all the bets on the beer header?
Yeah.
Okay. So on the right-hand side, that boundary beer router, it needs to track it now.
The one on the right, it will decapsulate the PFM messages.
But
It will cache the metric, but also forward a message in the PIM domain so it can reach any lost routers here.
So then PIM signaling needs to look at this new procedure or table to figure out where the egress routers are.
The only new thing in the PIM signaling is that the router here will look in its cache here to see which router announced the smallest metric.
So this is an additional procedure
so
to what we have.
Gotcha. Alternative to exactly. I think that's all I had. Okay, so just very quickly, if you choose to do this, we would need 2 new TLVs in this PFM mechanism. That could be a PIM document, or it could be down here. So it's basically announcing the beer info on the ingress router and this whole time metric group source whole time metric TLV. But the main thing is whether people find this thing interesting and if I should keep working on it.
Question of the room. Who's read the draft? Raise your hands, please. Who thinks this work should be adopted by the working group? So I saw, okay, put your hands back up if you read it. All right, keep them up. If you don't think it belongs to the group, drop your hand. Do you think it belongs? You think it belongs, you don't? You do. All right, looks like we lost a couple of hands out of the total. All right, we'll take this to the list and see where it rolls. If anyone's willing, if you don't think this is interesting work, can you comment now and maybe give some feedback, like why you think this is unnecessary, or you have a better idea?
Human Bitcoin Nokia, from procedure point of view, it's an extra procedure. So, more procedures, the better. But again, I'm not quite sure what is missing from finding the EBBRs with IGP. So we have IGP, we have BGP, we have a static route, we have covered the entire ground. Honestly, metric maybe, but I'm not quite sure what else. This is not bringing any traffic engineering or anything like that. It's just another method on top of, a hill of other methods.
Let's take the list.
Yeah. Yeah, I appreciate comments in the draft. So, thanks.
The dialogue is rolling. All right, next up, HTTP adaptive streaming. Excellent.
Use this one.
Yeah, left, right,
Okay.
or up, down. You want to use up, down. That turns it off. Left, right turns it off. There, up, down. Try again. All right, left, right.
No.
Huh. All right. Looks like it's still on. Maybe.
So this is the one.
This is the one. Let's see. That works. So we have this screen back.
Hello, everybody. This is the presentation for the draft applicability of BIER multicast overlay for adaptive streaming services. And I am Debashish and presenting on behalf of my co-authors listed there. So just as a recap, this is an example. This is a realization of the use case HTTP multicast that is described in the BIER use cases document. And in the earlier version of the draft, we described the reference architecture and realization of the multicast overlay. And we described this overlay over IPMC, IP multicast, and BIER. We did evaluate the pros and cons, and we went into a little bit details about the realization over BIER and described some of the operational details, including functional elements. In terms of the reference architecture that was described there, it is same. We just slightly modified the name. Instead of SR, we changed it to SH based on the comment. SH stands for Service Handler in the reference architecture. And just as a recap, in this reference architecture, the red boxes are the network attachment points, one on the client side and another on the source side. And these are basically egress router and ingress routers with this SH functionality. And we also have this function called a PCE, which is associated with the BRTE to support the CNAP and SNAP functions. And those yellow boxes are the source and the receivers. In terms of updates from the last draft, we did get some comments from the previous meeting in Montreal as well as in the mailing list. In terms of the comments that we addressed is the deployment options for the SH functionality in the BFERs and BFIRs, as well as to consider or describe the work that is going on at the other forums like DVB and BBF. So we did try to address those or include those, but at a very high level without going into details. Maybe some of the details needs to be hashed out further as a future work. And we also did some of the updates to the operational procedures with respect to the multicast overlay operations. Now, in terms of addressing some of the comments with respect to the SH deployment options, this SH, as we described earlier, is assumed to be co-located with the BFER and BFIR. But it is these BFER and BFIR are routers, and it may not be possible to add the SH functionality within these simple routers. So as an option, we described that we can consider this SH functionality. Maybe if it cannot be included in the BFER or BFIR, we can consider it as an external function, which can be a virtual functions, which may be co-located or can be located in a remote location. But in that case, we may need to define certain interfaces from the BFER, BFIRs to the SH. We again didn't go into the details of the interface, which may be a future work in the later updates. In terms of the work with respect to DVB and BBF, we did try to include some of the latest references from the work that is going on in the DVB. And what we found out in the DVB is very much basically similar, or it is, I think, it kind of based on IP multicast, and its architecture describes a multicast gateway. So which is, we think is similar to what we describe as the network access attachment points. And it is deployed, it can be deployed in many places like the CPE or the upstream network, edge device or the terminal. And it provides the multicast to unicast conversion facilities. So basically the multicast terminates at this gateway. And from there, it's an unicast to the client side. And so it also describes a specific interface through where the terminals or the content playback can send requests to the gateway functionality, and the functions that are included in terms of fetching specified type of content, conditional request, range request, and caching. And we also try to see what BBF is doing. So BBF is kind of following what DBV, but I think they are focusing more on the device management model. Now, in terms of this information, what we see is basically the draft already described how this operates on the IP multicast system, and we see it kind of very much aligns with that description in terms of the way multicast gateway is there and how the client sends request to the gateway for specific content or the streaming streams. So it's kind of similar, and from there we take on and continue on the IP multicast systems and its features and its pros and cons. So in terms of the next step, we are also thinking to include some additional use cases. So maybe we want to see if the working group has interest in including additional use cases for this such as file replication in CDNs or software updates over HTTP. And maybe the second question is does it make sense to adopt this draft by working group as an applicability statement documenting how BIER can be applied to aggregate HTTP responses over BIER infrastructure? I think that's it. Now, any questions or comments?
Albert Ratana, Huawei. I have a question. Does this, I didn't read the draft. You're basically documenting how it would work there. You're not proposing nothing. Signaling or packets or new bits or changes to the way it's handled in this application.
This is not any changes proposed to BIER. So this is an applicability of this use case we had about this HTTP response. So how that can be used over or applied over BIER, and how it improves over the.
Right. In other words, how to use BIER in that context.
So it does not propose any changes to BIER.
Right. Just a description of how to use BIER in that.
Yeah. How to use BIER. Yeah.
It's yet another overlay.
Right. So I guess the comment I want to make is whatever I think this work is good. I'm just not sure that it fits the charter.
The charter has applicability statements listed there.
Yes, the way I interpret that, or that's why I was asking about changes and et cetera. I think, and this is maybe a question for the chairs to interpret that, because I think it talks about how to integrate BIER in partial deployments, for example, and which means some of the other work that was presented before. How do I interface this with that part of the network running PIM or VPN and all that other stuff? It does have one item that says an applicability statement, but it specifically talks about the BIER and VPN draft. I mean, that one thing. So in any case, this is something that I think the chair should check the charter to make sure that we're interpreting it the same way. And if we are, good. If we're not, we should probably clarify for all of us, right, to make sure that we are looking at the charter the right way.
Right. So I already had discussion with Loa, because there's more of those drafts now floating here in this group where we don't really do the control plane anymore. So he thought it would be more in his corner. We have more than enough work.
Okay.
So original interpretation of this work, when it was introduced, we saw this as a use case or an application case of some kind. But if there's procedure changes that kind of go beyond just an application, then that might stretch the charter.
Right, and that's the other thing that the charter says. The charter says one use case document. So if this is a use case, then we can merge it with the use case document. Then
it specifically says one use case document. I mean, because honestly, a use case document could just be articulation without, detail specification. And I would expect a use case document that would be like a framework that we may want BCPs or even some, additional protocol changes to address a use case.
So what I like what you've done, don't get me wrong, I like the work. I don't want to get into a position where we now have 27 drafts on how to use whatever over BIER and something else over BIER, whatever. Because then
you're losing the bean counting. The applicability statement is in the charter. It says how BIER can be applied, as has been done for MVPN.
It's
well, as I said, the question is interpret the charter and make sure that everyone understands what the charter really says.
So I would say if we look at the charter and say that's not the case, I'm going to address that. I mean, if we could take a little time here, this array of documents you said may come from this idea of this over BIER, that over BIER. That's kind of inevitable. I mean, because if we don't say it's there, people, I've had to say, oh, this can't be done. What do you mean? Well, you guys haven't talked about it. Well, yeah, it can. Not understanding the actual operation of BIER and what it does, and it's not like we know it's an overlay, we know it's just an in cap, maybe some signaling to get it done, and we're there. But if someone, often they look at it going, well, crap, there's no coverage there. Now, if it's in the use case document, maybe it's not sophisticated enough to require something different, but if it does, the use case document should point, and it's further articulated in RFC fluid. I mean, it has to be a roadmap for a clue. Otherwise, it's just, we have some pieces and people don't know how to put the puzzle together.
We can discuss this more later. I just feel like we may be opening a door that we maybe later want to close, and we can't. So in any case,
Close the working group, you said?
No, the door, not the working group.
Okay. Yeah.
Are you complaining about the working group?
I just got here.
Okay, good. Okay.
Yeah. Beer's done.
So I think in the IETF multicast overall,
Name?
Tollis, Eckert, been fairly good in, making application developers happy as long as they were providing network transport services, right? So everything about VPN and anything else, and done a pretty miserable job in explaining how to use multicast best for other applications. And BIER being very much in its infancy, I was joining this because I thought this would be good documentation of, this HTTP streaming use. And the use case document, I don't think should go into all these technical details of a particular application space. So I don't really care in which working group this is best positioned. I think, the folks in the room and, should decide if this is worthwhile to be documented as something that at least gets working group review. Which of the working group it is, MBOND or BIER, no opinion.
We need we need some.
Yeah, just a quick on Andrew Dogan on Nokia. I think we do need informational drafts. Like, it has to be informational. We need to do this. If there is extra other work, then we can discuss charter, non-charter. But it puts ideas into people's head as well, and so it's not, and that's innovation to me. So,
Excellent. Thanks. All right, one more comment.
It's marketing, but we call it innovation here.
Yes, young man. Can I help you?
Alvaro, again, just one more question, just to be clear. The working group makes decisions. I can say whatever I want as a working group participant, but I could be in the rough anyways, right? I just want to make sure that we keep up with the load and everything else. And if there are things that we need to do or want to do, the working group wants to do it. I have no choice at the end to help the publication.
So
don't
I think,
take this as me saying stop, right?
Thanks, Dad.
And yes, we're not closing the working group.
No, so I mean, the applicability seems more natural to be here because it's centered around this specific technology. Whereas the control plane stuff, like we were talking now, all the additional MVP and procedures, whatever, not signaling stuff, that could arguably go into people who deal with this signaling, right?
Well,
And I think that was the discussion we had around the charter when we were putting it together.
Right, and Greg as chair warned you in advance, this is one of my many soapboxes, but multicast is always that bastard stepchild in the corner. You go to the other groups, they say, yeah, it's kind of, we'll get to it. So even getting their help, they've never even thought about it for multi-point or replication services. So oftentimes the work's got to start here to shake people's, and then we find them, like I said, you review, please help us look at this. We needed these services, you're the expertise, help us, integrate. But the innovation always, the use case, the need always arises from this group of people. I was just thinking, looking at faces like Torres got the mic, it's like, I laugh, but I've been seeing Torres the mic for 20 years. It's like the same people in the room, it seems like, to some point, but we stepped in it, right? And it's on our shoes, and no one else in the IETF stinks like we do. So we're the ones often stuck trying to identify the problems as well as solve them.
So Law asked me specifically, Alvaro, to be in the MPLS or one of the chairs lunchtime today. So I'll be there. So maybe Laura climbs on a soapbox and goes about, I want a piece of the stout. It's fine. I mean, you see, we have enough to do. Okay.
All right, let's test the room. Who's read the doc?
Yep.
Its current form. Okay, who thinks this is something we should consider adopting here in the group?
Yeah.
Hands stayed up for the most part, except one of the co-authors dropped his hand. Okay, please let the minutes note that we'll take this as a list for adoption and we'll run from there. Thank you very much.
Thank you.
All right, sit back down. So Trollus, you were next. Somehow I got you bumped off this thing. It got moved around. All right, there you are. Just in advance, it's an early morning. Let's forgive Trollus for not wearing blue shoes. It's a shock to most of us, I understand, but we're just going to roll with it.
I know, so much as of a disappointment to you. Okay, next slide.
No, you're in charge now.
Really?
Oh, yeah,
This works? This is the first?
I got fired.
Working. Oh, okay. All right, so sorry, I had my own working group conflicting at 102, so this is a little bit late update from what was presented at 101, so I updated. the document focusing on what I think is really the core part that I think is important to do, which is specifying the details of the forwarding plane, and as Aliyah was pointing out, any possible differences over beer, and making clear the goal of the document is to be able to enable building of forwarding hardware that can support beer and beer-TE, specifically intending the document to be experimental, in my opinion, because I think you can perfectly well build experimental networks without defined control plane by, for example, just programming the BIFT, but only once that has shown successful, and basically the whole shebang of the traffic engineering, appropriate protocols, everything really makes sense to get into. I started to put a couple of drafts out around 101, but obviously all those control planes stuff would take a lot longer. So experimental for now to gain insight that this will work and can be done, and then go back to the control plane. So we had the discussion about the encapsulation. There have been proposals from us for enhanced encapsulation over 8926. Specified in this document that 8926 can be used unchanged, with just the need to be able to configure that a particular subdomain would have the beer-TE semantic as opposed to the basic beer semantic, and I'll send in a second what that means. And then the additional encapsulation draft that we have, I will basically not refreshing them right now, but they would be for additional enhancement, and I think primarily the one for the DetNet benefit of indicating sequence numbers. So I think we'll basically figure that out later in respect with those use cases. Okay, so I added a new section 3.6 requirements with must should against the details of the forwarding plane, and that I hope is similar, but hopefully also very explicit to beer, where I think the way I read it, ECMP was an optional addition, but otherwise the most core beer forwarding was mandatory. So here we go. So must configure subdomain for beer-TE forwarding. And then basically the semantic of the bits, which are really the minimum necessary, are the bits indicating no or one adjacency, and the adjacencies could be either link layer or forward routed, where it would be encapsulated, for example, in an MPLS label to be sent to a remote node, or local decap when you receive it. So we could maybe degrade to a should the forward routed, but I think it's really for the typical topologies we've looked into, it's really very important, I think, to have that ability with the adjacency. But I think these three together are very simple and make it, the closest in requirements to the beer forwarding. So it should do the do not reset flag, because that's really good to have just 2 bits for arbitrary large layer 3 rings, and it may have ECMP adjacencies or more than one adjacency on a bit, right? So that's basically trying to prioritize the functionality. Okay, so here's basically then, can you hit this full screen button?
It is full screen.
It is? Oh, it's,
yeah.
No, it's
you
not.
just do a shitty selection of fonts.
That probably too, yes.
No, this gets converted to the Chromebooks.
Oh, okay. Yeah. Okay, so this is basically, now I have 2 pseudocodes in here. So this is exactly the same pseudocode as beer has, to highlight if one exactly has the FBMs in the forwarding plane implemented to reflect what the beer forwarding draft does. Then there is basically the problem that for beer-TE, this is uncommenting in this pseudo language, that we basically would not reset the bits in the string after every individual replication. And here's the explanation, which is basically that in beer-TE, we're not looking at all the bits and are only going to continue looking at the bits of the outgoing interface we're still interested in. So we reset all the others, but basically all the others I might have ignored, but further down on the path, they may be looked again at, right? Because we only have the adjacencies for those bits that are really adjacent. So think about this. This is what's basically trying to make it compare very easily to the beer forwarding. And then here is the second solution, which doesn't rely on having the FBM. So that's just a matter of local optimization, how you want to move it, how you want to implement it. This is just showing really that you don't need FBM bits. It's good enough for each adjacency to just have the do not reset flag, and then basically you're just resetting this bit itself on which you were doing forwarding. So you don't really need to do anything about any of the other bits in BIER-TE. And then this is longer because it just also has the pseudocode for the different type of adjacencies, which wasn't done in the BIER pseudocode. So I thought it makes it easier to understand what all these different adjacencies do a little bit, but let me know if this is the best text or we should cut out the adjacencies like it was done in BIER. So what else? So that was really the core of interest. I added some opportunistic text, which, you know, please tell me if that's good, 1 or 2 paragraphs at the end, how BIER and BIER-TE might best be understood by somebody coming from the segment routing side. So that really in BIER, you know, the bits are equivalent of destination node sits, but instead of, you know, wasting 32 or 128 bits, we have 1 bit for each of them. And then in BIER-TE, you know, have 1 bit equivalent of every, you know, intermediate sit that we have in an MPLS or SRv6 sit stack, and we can of course do trees. So that was basically an attempt to better relate to that unicast technology, because today I think we're seeing everybody goes another evolution step with SR on the unicast side, and then everybody says, oh, that means in multicast we need to do the same thing as much as possible. I'm saying, well, we're doing logically the same thing. So marketing. So let me know if this belongs in this document or not. So credit rolls, the end. Oh, wait a second. So while doing this, there was one funny, cool, crazy thing about the BIER architecture thing, and I just had to reuse my gigometer from old times. Let's think about here. You have this BFR, these 2 links down there, 3 BFERs on the edge side, and I'm now crazily, I'm thinking I have direct access to the BIFT, and I'm setting the FBMs directly to bit strings that I like, basically I can really get crazy results. Whereas if, you know, bit number 1 is set and bit number 2, then basically my packets to BFER2 go this way, while if BFER bit 1 is not set, the packets to BFER2 will go this way. So that's the fun and crazy part if I'm just sending FBMs. Now, in BIER itself proper, the way it's specified right now, this wouldn't happen because there really, so far is, I think, no defined access directly to the BIFT and the FBMs, right? We don't have an API to do that. So they would only be populated from the BIRT.
Wrong. So first, the Yang model, I'm pushing to allow that. We should have a read-write on the BIFT that's fully intended with the architecture. Okay. Second, wrong. What you say, what you describe is the deterministic, non-deterministic ECMP. And it's right in the architecture.
No, it's not ECMP. No,
it's the same thing.
No.
Yeah, the destination bit mask determines how you will route through the network. That's non-deterministic ECMP. Same thing. Okay. So it's not crazy. It's unintended, but it was there from day one, and people knew that. But yeah, effects are funny.
So right. So the thing that I was thinking of this, I can reread it. Maybe I misunderstood it. I think there is no ECMP adjacency in here. This is just setting FBMs differently. So that was not my understanding about the ECMP procedure.
Yeah, okay, yeah, so fair enough. Architecture document talks specifically what happens on the ECMPing, but it's related. Okay.
Okay, well, again, I don't want to spend too much time. The only thing where I was thinking this might be something that we could do with the FBM, but maybe don't want to allow doing it, is that if I want to do a distributed egress implementation of BIER, I would like to try to have to look only at the bits that are of interest on the egress line card. And if I have really the original semantic of the sequential resetting of the bits and allow these type of, you know, FBM settings, then I couldn't really have scalability in the order of each line card only having to look at the subset of bits that are, you know, on the line card. So that was kind of, yeah, this is too much to comprehend completely within the time. So, but I thought it was funny, quaint, interesting, maybe something where we want to say, let's just, you know, if we mandate how the BIFT has to work when you program it directly. So yeah, good to know that.
Okay.
Then maybe we put constraints on what allowed FBMs are, because maybe a distributed implementation may not want to, you know, support that crazy FBM combinations.
Yeah, that's interesting consideration. But actually what you say is, for example, fully intended if you would build something like a 2-stage replication chassis and use BIER inside, then you actually rely on these kind of effects.
I don't think so. I think if I just look at, if I ignore all these ECMP things, I'll drink more wine or beer and we
Mhm.
go over these things again. But,
Beer, please. Yeah.
I think that just BIRT is perfectly fine. I can basically on each egress line card only look at a subset of the bits that I know have any adjacencies on the interface. I don't need to go through the other 200 bits. So if I have, a big box that has 100 egress line cards, right, I can scale better if I don't need to support this craziness.
Okay, offline. Interesting consideration, because the BFR2 and BFR3 may be your fabric, in fact, and then all kind of other stuff kicks in.
It was just line cards with these interfaces, but yeah.
If you go through the fabric, on the other side, do you another stage replication, then these things kicks in. But yeah, interesting consideration.
Yeah.
Does it belong in the BRT draft?
No,
Probably not, but it belongs somewhere.
I didn't have it in there, but it just came out with me thinking that in BRTE, I definitely want to have explicit access to the BIFT. I don't really need the FBM. We have to figure out if we want to still represent it. We could, but then if it's a BRTE thing, we of course would only support a much smaller subset of FBMs.
I think this discussion belongs into Yang draft, because the Yang draft is really showing the guts. And the question is, do we allow the BIFT as a read-only or as a read-write object? And I was pushing for a read-write object, which I think architecturally we should allow.
Just some clarification. So if you say BIFT1, BIFT2, are these different BIFT tables, or is this the same table? Because
the stuff that wouldn't happen if you're letting ECMP away is that you would set 2 bits on these both adjacencies, right?
So I think what the architecture draft says that you cannot have the same bit set in 2 different forwarding entries in the same table.
I haven't seen that. If that is there, then that would already be safe. So I'll have to.
Right, and that's why for ECMP we create different tables, different ECMP tables, where each bit is only reachable through one adjacency.
Okay.
I'll try to find it myself again in the RFC. If I don't, I'll ask you again. But
no. Yeah, ICE is spot on, because otherwise you would generate replicates in your networks, right? Unintended replicates anyway. Still, the question whether we allow our RW on the Yang BIFT object stands, and I think it is a significant decision that has to be made by the group architecturally. Yeah.
One more last, Sandy, then we got to roll. Go ahead.
Sandy Zhang, ZTE. As the co-author of BRT Yang, I'd like to say the FBM in the Yang is read and write. Okay.
Right. And then if you program this stuff that way and generate replicates within the beer replication fabric, by all means, you better know what you're doing when you're fumbling with the bit masks. Okay. It's programming assembly, right?
Actually, ICE, would you mind going next? You've got a really short presentation. I don't want to see this get wedged at the end. So that way Jeffrey's got the next 2 after you and he'll wedge himself. Is that fair enough?
Yeah, I can be quick. I can maybe get you 1 minute back.
Yeah, there you go.
Yeah, good.
Hello, yeah. Okay, so ICE, Cisco. So just a quick update on this draft. Since last time, well, we didn't present it last IETF, but so it has been accepted as a working document. And based on some comments we had on the mailing list, mostly with Eric Rosen, so we added one actually additional encoding to this draft. So this is the one that we already had before, right? So we're hard coding bit-string length, subdomain, and set identifier in the 20-bit BIFT table ID. This is nice, if those values are sort of well known and you want to create a unique BIFT ID based on those values. So, and by the way, this is for the non-MPLS encoding, right? So that's all good. And now we actually added a new one for a couple of reasons. Now, as you can see, so IBU has made it into a beer. That was funny. So this is basically the identifier now in combination with set to create your BIFT ID. And the IBU basically becomes sort of like your label, right? And reasons for doing this is actually, well, a draft that Jeffrey is going to present later on, like with beer as a service. If you want to add an additional identifier or, to your BIFT ID, because today we have subdomain, bit string length, set ID, But if you want to add something else to it, right, and create still a unique BIFT ID, then obviously the previous encoding doesn't work, right, because there's no space in the 20 bits. Now, with IBU, it basically becomes like a label that you can still use to create a unique global ID for the BIFT ID. And the benefit of still having the set ID there, and maybe I'm explaining this here. Oh, yeah. So with MPLS, we allocate not a single label, but we allocate a label range, right? Like 256 to accommodate the set identifier. So basically that comes down to the same thing as that we're doing now here, right? But we just pre-allocated already as the set identifier, right? So you only need a single value for IBU, but it automatically means you got 256 sets to use with that. So basically, so that's what's the point. So if you do want to have other, let's say, ways to create your BIFT ID, then you can do this now with this IBU value. Also, and that was a point that Eric Rosen made early on. Hard coding fields in the BIFT is a bad idea because we want to keep the separation between control plane and the data plane, right? In the data plane, it should be a 20-bit value, which should not be parsed by hardware, right? Although if we're going to create encodings that actually now carve it up, they might do that. But in this case, now we have two encodings, right? So basically, you cannot really parse it anymore, right? So it's a sort of secondary fallout of this solution. That's basically it. Questions?
So I had an exchange with the other author, I think, that the value 0, right? This is the one with the value 0, meaning that those are the generated one, the like what were we calling them? You have the values 0 is reserved, right? When you carry the 0, it means now it's the non-MPLS automatically derived one.
No, there's no hierarchy here. These are separate encodings. I'm not saying which one you're using. So you have to, it's by policy, right? By configuration within, and it's domain-wide.
Right, but the 0 was reserved for the one that the draft says, and otherwise you have to carry them around. Maybe also I'm getting uncharacteristically or characteristically a little bit lost, but the important thing is the flat 20-bit in the hardware. I'm happy. Eric's my point has been made. That's the point. The rest is yeah, cool.
Wednesday morning here in Thailand with friends. You're okay. You're not lost.
And I even checked out yesterday night. Gave up.
Any questions? Comments? Already
You
adopted.
Yeah. So please give comments, and maybe we can progress this also. Last call. I think it's quite simple. And
So you have, is it 2 authors on it?
Three.
All right. Well, we'll follow up an email with the authors and make sure you guys are ready with the latest rev as last call, and we'll take it on the list. Please note that in the minutes that it's an option for last call in this draft. Thank you. Jeffrey.
This is important. This is the presentation that they gave. They want basically Mexico field starting to describe what is the MPLS, what kind of MPLS label I can
Understand you have.
You have 20 minutes to do both of yours.
I lost 10 minutes. Okay. So the first one is about beer tethering, or however you call it. Start with the brownfield deployment. How do you handle beer incapable routers? I have this diagram here. X in the middle does not support beer, others support. So you either get around the incapable routers or tunnel through them. So the first case is that we get around it, even though the shortest path to all those BFERs on the right side is through X. But when it comes to beer, we get around the X. We don't use X. The next one is tunnel through it. So the section 6.9 of the architecture specs talk about a way to do this. Basically, at the end of the SPF calculation, in this case, BFR1 is doing the calculation, and it gets the SPF tree with X being its immediate child, and then others as the child of the children of X. So it examined the immediate children list, and for anyone that does not support beer, it replaces that child with its children. In this case, so BFR 3, 4, 5, 6 become the BF1's children on the SPF tree, and then you just tunnel the packets to those guys. So this is what we just talked about. Notice that any tunnel can be used to reach that child. It's static or dynamic. And there is one important property here that you do not need to announce those tunnels. Sometimes tunneling alone may not be good enough. In this example, BFR1 needs to tunnel 4 copies to BFR 3, 4, 5, 6. Now, if the connection between BFR1 and X is bandwidth constrained, then that's not good. So one way to get around this is that we tether a helper, or we call it BFRX here, next to X. This could be done via a local fed pipe. And now the packet could be like this. The BFR1 only need to tunnel 1 copy to BFRX, and then BFRX will replicate and tunnel many copies to as needed. So far, it all worked, except that those tunnels need to be announced in IGP. Otherwise, BFRX will never be put into the SPF tree. And announcing those tunnels in IGP is troublesome. But there is one way to get around that. We call it a trick or whatever. So basically, X could pretend that it supports beer. So it does whatever a BFR does, advertising labels and all those things. So it will get beer packets from BFR1 with beer labels. Typically, the beer labels will lead you to do beer forwarding. But here, the beer label will be used to label switch the incoming beer packets to its helper, in this case, BFRX. Once the packets get to the helper, the rest will just kick in automatically. It works out fine. So now the BFRX needs to know that that X, even though it advertised all those beer information, the X does not really support beer. And that information could either be signaled or be provisioned. So when it's done by signaling, there are 2 ways to do it. One is that X tells everyone that BFRX is my helper. And that way, BFRX will know that it cannot just send beer packs back to X natively. It needs to tunnel. That information also allows other BFRs, for example, BFR1, to use section 6.9 method to tunnel packets directly to X instead of relying on X to do label switching. There is another way, other way around. Instead of X says that BFRX is my helper, BFRX can actually say, I am X's helper. I'll talk about what's the difference. For the 2 options, where the first one is X pretends that it supports beer, but does label switching, that you only require software upgrade on X itself and its helper. But it only works for MPLS. It does not need any software upgrade as long as they already support beer on other BFRs. The second method is where the BFRX advertises that it's X helper, and then others will tunnel to X based on that signaling. That one, you do not need to upgrade on the incapable router. Sometimes that's necessary because being an incapable router, sometimes you can even upgrade its software. So anyways, basically just 2 options. So we're seeking comments. We'll probably polish the drafts more, and then request for the option. No, not immediately now.
Comments? Who read the draft? Okay, highly encouraged.
Sunny Zhang LTE. I think the control plan is good, but I want to know more about the data plane because I want to know how the packet will be forwarded in the X router X. Should X support P2M PRSP or other thing?
No,
Just multicast
no.
flow
Yes, the question.
forwarding.
The X here, it gets a native beer package,
Native.
right, from BFR1, and then it will just using the beer label, a label switch to BFRX. That's one way. Another way is that BFR1 tunnel package directly to BFRX, and that's just unicast tunnel. It's not P2MP.
Yes, I understand. X must forward the packet according to the label, right? But this in ingress label is point to 4 in this picture, 4 same label out, right? You will use the same label for the forwarding or the different label for
that does not necessarily need to be even specified because the X to BFRX are basically proprietary procedure if you want. It's a hidden label. Whether you do a label swap there or keep the same label, do we even
same label
standardize that? It's not even necessary, I think, to standardize that.
Right. Another thing is that notice that here BFRX also advertises its beer label. So when X does a label switching, it could be swapped out the incoming beer label that is advertised by X, and so replace it with the beer label it receives from BFRX.
Yeah.
Okay, and so X will support the functions that they will choose, they will execute the label.
But think about a very extreme design point where you don't on X even do any MPLS switching. You just see the label, you map it on some fixed table, and you put in a GRE tunnel. It pops out on the BFRX, and the BFRX takes all the function over.
Okay.
Okay.
Okay, thank you.
And this will be more expensive. You do realize that, yeah? This at the end will be more expensive.
I don't see dollar signs in the charter.
No, well, I know, but
Look, Andrew, it can be actually less expensive.
When you
think through the point that you have to implement the whole multicast functionality in X, which costs you more per bit, no matter what you do, whether you run multicast or not. And the BFRX has only the size of your multicast flows.
you can design this by stitching in BFRX without all this stuff. If you start proxying like this, you're replacing optical layer, which is cheaper than routing layer, with routing layer on a cost. So at the end, it's great. I'm in the router business. I like it, but
I actually don't follow, but I'll follow up with you offline. Yeah.
All right. We asked who read. Who thinks this is something we should consider as adoption? I mean, it's got to be polished first, but I'm kind of just going to read in the room. All right. There. All right. So if you're going to be revenant, then just kick us some more.
Yep.
Get the conversation going. Thanks. You're next, right?
Yep.
Cover this. Cover this.
I'm finished with this. Yeah. Here or multicast as service. I'm just going to skip a lot of slides. I talk about why multicast as a service has not become real and why it may become real, and let's just jump to how this could be done. Using a simple example, where a single operator doing multicast for its what needs. For example, it could be a content provider using multicast to distribute the video traffic, ultra high density, high definition. Yeah, and imagine that they buy into this multicast idea and they want to do beer, and they have BFERs all over the place, spanning multiple ASs. In the middle, we have AS200, and then there's some edgy ASs. So initially, they could start without transit BFRs at all, just BFERs. And in that case, it will be just like ingress replication among each other, but using a beer header. That's fine. You can start with that. Oh, this is PDF. I guess I lost the animation, but that's okay. So then you can gradually add more BFRs, transit BFRs in the network. For example, you could say that ASBR23 and ASBR24 are now upgraded or replaced with BFR. And now the replication is no longer ingress replication end-to-end. For example, BFR 11 will now ingress replicates to ASBR 23, who will in turn replicate to others, so on and so forth. This is all based on BGP signaling for beer, except we need to make a few enhancements, a couple of enhancements. In this example, let's say that for BFER 11 to reach BFER 42 at the bottom, the best unicast path is through ASBR 21. Let's see if I can. There is no laser, is it? Okay. It's through ASBR 21, but ASBR 21 is not beer capable. Instead, ASBR 23 is. Then the best will be for the only ASBR 23 to announce the BFER, the BFR IDs and routes for beer purpose. And that is one thing. Another thing is that today the IDR extension for BGP beer signaling does not clearly specify how you decide where you send your beer packets. So in this example, the BFER 42 at the bottom sends the advertise a beer prefix and goes through ASBR 4, ASBR 24, ASBR 23, and then ASBR 1, and eventually arrive at BFER 11. Now, the beer next, then BGP next hop in that advertisement is ASBR 1. And so does BFER 11 use the next hop to send the beer packets to, or does it use the beer prefix itself to send traffic to? Obviously, if you use BFER, you use the BGP next hop, the ASBR 1 is not beer capable, you get into trouble. And if you use beer prefix itself as the next hop for the beer, then you end up with ingress replication to BFERs. So to solve that problem, we can introduce a tunnel incap attributes attached to the beer prefix advertisement that is attached by the BFER itself. And whenever it goes through a BFR that changes the BGP next hop, that BFR will change the tunnel incap attribute so that it will becomes the BFR itself in the middle. That way, the ingress BFR, the BFIR always use the tunnel destination address in the tunnel incap attributes to send the beer packet. And inside the particular, so far we're essentially doing OTT. We're tunneling the beer packets. But inside the area or AS, when you have enough routers supporting beer, you can also start doing beer in there. And notice that when you do that, you will still, so far we're still talking about single beer subdomain. It's just that part of it is using BGP, part of it is using IGP, things like that. And you can, and there is this draft that Cindy just presented that will help us just redistribute routes with beer informations. Segmentation, I'll just skip it for now because we don't have enough time. Now, so far we haven't really talked about service yet. This is just a single CDN's network. But if you imagine that AS200 in the middle does not belong to that operator itself. It belongs to a service provider like AT&T, Verizon, whoever. What that means is that AT&T or Verizon is providing multicast transport service to this customer. More specifically, it's actually beer service, transport service. So that's where the title, the trendy title comes, where multicast as a service or beer as a service. So again, provided by AS200, it's at the beer level, but there is no BFER for that provider. So it does not maintain customer states. And more importantly, a provider can provide beer transport services to different customers independently. And those different customers, beer domain or a BFR ID location, they could conflict, but we can still support that. To do that, we should introduce, we need to attach a route distinguisher to the beer prefixes. And now a BFR in a service in this provider just need to scale on the number of BIFs. One example is that if you need to support 256 beer customers, then you will need to maintain 256 BIFs. And if each BIF is 256 bit down because your BSL is 256, that means you will maintain 64,000 routes for beer. Notice that this should not be a big concern because on the unicast side, we can do many, many routes already. And the beer route and unicast route, there's really no big difference there. And also 256 beer customers, it sounds small, but it's actually, I think it's practical because notice that we're doing the beer transport service, and that beer, the customer's beer can be used to do for many, many things. For example, the customer's beer could be its MVPN provider tunnel. So you have levels of aggregation there. Yeah. Control and billing. A provider can have policies to control whether it re-advertises its certain beer prefixes, how they advertise this, and it also can decide whether it advertises its own beer prefixes. Beer prefixes, but as long as you don't advertise your own prefixes with the same RD, that means you are just you're not doing instantiating your BIF table, and you're just being actually just being a transit point for the control plane and for the tunnel that goes through you. And the provider can count the traffic and bill accordingly. For example, at the entry point, the income beer packets for each beer label, you can count it. At exit points, you can count outgoing packets associated with each outgoing beer label that it imposes. So, summary, we can provide scalable multicast as a service, and that's enabled by beer. It's actually incrementally expandable with policy control and billing. So there, I skipped a lot of details. It's in the spec at the draft, and of course the draft can be further improved a lot with comments and contributions here. So.
Yeah, the 256 comment. Okay, that's maybe we have bigger networks, but 256 is not a lot. This is what my I'm not gonna say issue, my dilemma with this is when we started beer, the whole paradigm was we need something simpler. And the beauty of beer was it was really simple. And for a first time, I think people who do not understand multicast could actually follow it. So go back to your slide with like multiple ASs and stuff like this. Yeah, this one, it's a good slide. Yeah, good luck with 256 on that type of a network. Those are problems that can be technically solved, and this draft solves one of those problems, no question about it. The thing is, are we doing ourselves a favor because we introducing a level of complications to deal with things like that? So before we do that, I would really like to understand the practical use case. Otherwise, we're going to have a complicated standard that do not solve use case. I have not seen personally a multicast deployed in a network where the edge devices were doing it before anything in between. And here we're trying to do those tunnels and everything, and so may as well do ingress replication and other stuff like this. I'm just saying we adding complexity levels, and that will at some point turn away people from looking at
so we're tight on
my
time.
concern.
I think your point is we need boil it down, and forgive me if I'm wrong, better articulated use case so that we can focus the complexity, why it's there, and not just create a solution looking for a problem.
Yeah, so it's very clearly put into this is the use case we're solving. And then people can decide, oh, it's practical, it applies, or they can say, okay, I don't have to even look at it because it's a corner case of some sort. And I'm not saying it is, but I want to make sure that we do not add various complex procedures and make away from perception, and it's a right perception in the sense that beer in itself is a very simple way to deliver multicast on the network.
You know this is multicast, right? Where every use case is a corner case.
Thomas.
No, if we try to do this like that,
Oh no, sorry, that was Pim.
I'm
Yeah.
not gonna go in there.
Yeah, Thomas Eckert. So yeah, a little bit also around this build it and they'll come issue of, is this the right time to do this, right? So on the positive side, I certainly think we should have a good feeling whether it will be possible to sell beer as a service, right? So the goal is great. Whether we should work through all the details right now to make it into, standards procedures, I think is a different question. And from the use cases, I think there are two big ones to me, right? The first one is applications using actually beer, like the stuff we talked about. And we're by far not at the point where this happens, right? I would like to accelerate that. Once that happens, pretty sure we need this. The other one seems to be, I'm a service provider offering some multicast service, and I have a choice of what type of underlying service I can buy, right? And if I'm only offering IP multicast services like VPNs or so to my customers, and I'm trying to buy underlying connectivity, right? Why would I want to buy, something new? And so that what does it give me if I'm right? What does this give me as an overlay network multicast service provider that's offering just IP multicast? What does beer that I buy from somebody else give me more? I think that would be good to formalize.
Out of time. This is exactly what we discussed. Let's articulate the use case before we go into detailed machinery.
I was just trying to get one level more detail on that.
Well, let's do that on the list. I mean, if you want to contribute, Jeff and I talked a little bit. I've got some kind of shadow cases, but we should focus this down to something so we know. Otherwise, every overlay becomes that corner and you start building machinery that we've discussed. All right, so we have more slides on this?
No, I'm
All right, done. Who's read this draft? All right, good. We a lot of them. Who thinks, without saying a dot, but we see shadow that this is something that could be interesting to the working group, possibly for adoption. All right, good. So if that's the case, let's focus that input on what are these use cases we solve. And it's always this challenge. We can create the technology, but there's often business barriers or licensing barriers or whatever it would be. If we can, if you guys know operators or in touch with operators where they're looking at something like this, then we can better define the problem. Then we can focus the solution on those problems and grow from there. All right. Who has not signed the blues? We got blues up here now. Blue sheets. Anyone not signed the blue sheets? Excellent. Oh, just back to this use case again. How many people here last night spent money on beer? Yeah, see? Yeah, we're all spending money on beer all the time. So I think we use cases are very well defined. All right, thanks.
It was not televised.
No, it was not televised, exactly. All right, thanks, everybody. Be in tomorrow. We got another hour's worth of this fun. And those of you who have not sent me slides, I think there's one of you left. Please update them as quickly as possible. Thanks.
So we return it just to the reception?
Yeah.
Secretary?
Oh, you got it.